We are in quiz 2 of day 3. Question 1. Limit x approaches 0, tangent 2x over tangent 4x. We are in the 0 over 0 case, but there is a short way. Just focus on the ratio of coefficient of x. 2 over 4 is 1 over 2. 7 minus 7, the second question, limit x approaches 0. 7 minus 7 cosine x over 3x. 7 can be taken as a common. 1 minus cosine x over 3 times x. There is a rule, 1 minus cosine x over x, as limit x approaches 0 is 0. So 0 times the coefficient 7 over 3 is going to be 0. Question 3, limit x approaches 0 sine x square over x. Sine square means writing sine twice, sine x times sine x over x. You may use x for the first or second sign, no problem. Limit x approaches sine x over x is 1. Since it is alone, I need to do substitution. Sine 0 is 0. 0 times 1 is 0 as the answer of question 3. Question 4, tangent square x over x. Logic is the same. Like tangent square is a product of tangent and tangent. There is only one x, so use x for the first or second. Tangent x over x will be 1 as x approaches 0. The other tangent will be alone, so do direct substitution. Tangent 0 times 1. Tangent 0 is 0. 0 times 1 will be 0. Answer of question 4 is C. Limit x approaches 0, x minus sine 2x over 3x. Actually, it is the 0 over 0 case, but the shorter way is we are just going to focus on the coefficients of x. 1 minus 2 over 3. Numerator is negative 1, denominator is 3. Answer is going to be C. Question 6. Limit x approaches 0. Cosine x times tangent x over x. I can use x for cosine or tangent, but there is no rule about cosine x over x. So take x with the cosine. Tangent, sorry. So it will be cosine x times tangent x over x. The case is limit x approaches 0. X approaches 0, tangent x over x is 1. Cosine needs substitution, cosine 0 is 1. 1 times 1 will be 1. Answer of question 6 is A. Question 7. Tangent x times sine 3x over x squared. X squared can be written as a x times x. So for each part, if you take x for tangent and sine, you can use the rule. Tangent 2x over x, x approaches 0 is 2. Sine 3x over x, x approaches 0 is 3. Product of them will be 6. Answer is 6. Sine square 2x over x squared. Direct substitution is going to give us 0 over 0. For all 0 over 0, you may use L'Hopital, but I want to use the rules of sine, cosine, tangent. Sine square can be written as a sine 2x, sine square 2x can be written sine 2x times sine 2x, and x square can be written in denominator as a x times x. Each sine can take one of the x, so one of the parts sine 2x over x, so it is 2. The other part sine 2x over x is 2. Operation between them is multiplication. Answer is 4. Question 9, it is not multiplication, it is summation. So I am just going to focus on the coefficients of x. Pay attention, all these operations are 0 over 0 case. 2 plus 3 over 4 will be 5 over 4 as the answer of question 9. Question 9, answer is A. Question 10, it is rational, maybe it is 0 over 0. Without direct substitution, I cannot decide. Write 5 instead of each x. 25 minus 25 minus 5 over 5 minus 5. Numerator will be number, denominator will be 0. It is the case, limit doesn't exist. Question 11. Sine square 3x tangent to x over x cubed. So sine square 3x can be written as a sine 3x times sine 3x, tangent 2x, x cubed in denominator can be written x times x times x. Each trigonometric function can take one of the x, so limit x approaches 0. Sine 3x over x is 3. sine 3x over x is 3, tangent to x over x is 2. All this product, 9 times 2 will be 18. Answer is C. It is rational. I need to check which case do I have. X, write pi, we need to write pi instead of x. Pi minus sine 2 pi over 3 pi. Sine 2 pi is 0. Numerator is pi. Denominator is 3 pi. Simplification is going to be 1 over 3. Question 13. Normally we had 1 minus cosine x over x as a 0, but it is not the same rule. The direct substitution is going to give us 0 over 0. So 0 over 0 is the case of we can use L'Hopital. By using the same limit, take derivative of numerator. There is minus sign, and cosine 3x, derivative of cosine 3x will be negative 3 times sine 3x. Derivative of denominator is 2x. Operation in numerator is 3 sine 2x over 2x in denominator. We have limit x approaches 0. Limit x approaches 0, sine 3x over 2x is equal to 3 over 2. And we have 3 here as a product. 3 times 3 over 2, 9 over 2. Answer is B. Question 14, there is a subtraction with absolute value stuff and limit x approaches 0. Actually, direct substitution is going to give us 0 over 0, but it is not case of L'Hopital. We should write limit from right and limit from left. I just want to show you, if I use for each absolute value, I should know which type of inside do I have. Positive inside is the case of I can write my expression same. If the inside expression is negative, so I should take my expression with minus sign. Let me see the both approaching. Limit x approaches 0 from right. Choose any number which is greater than 0, but don't go so far. I want to choose 0.5. The expression absolute value of x plus 1. By writing 1.5 here, inside will be positive, so my expression will be same. If I write as x approaches 0 from right, if I want to simplify the other expression, 0.5 minus 1 is negative, so negative inside needs minus in front of my expression. Limit x approaches 0. I just want to see which type of outside do I have. You can use negative 0.5. If you write here, it will be positive inside, so my expression is the same. And if I write negative 0.5, it will be negative inside, so there will be minus in front of my expression. I just want to show you one approaching, you may do the other one. But if I pay attention from both approaching 0 from right, 0 from left, my expression is going to have the same outside. There will be minus in front. So limit x approaches 0 from right. The first one is positive, it is going to be same. There is minus in my operation, so I put minus sign. The other one has minus in front, so this is my expression without absolute value notation. So numerator is x plus 1, minus minus will be plus, x minus 1 over x. Plus minus 1 can be 0. Numerator is 2x, denominator is x. It will be 2. The other approaching is also going to give us the same value. Whenever the limits are same from right and left, limit exists, which is equal to 2. Question 15. Limit x approaches 1. So it doesn't give me any problem. I need only a direct substitution. 2 times 2 plus 7 in square root minus 3 over 1 plus 1. 9 minus 9 under root will be 3 minus 3 over 2. 0 over 2 will be 0 as the answer of question 15. Question 16. I have also 0 over 0 case. If I do direct substitution, it will be 0 over 0. But whenever I have absolute value notation, I have to be careful. It depends on my approaching. If I approach 1 from right, and numerator also can be factorized as a x minus 1 and x minus 1. Approaching from right, use any number greater than 1, so it gives us positive inside. So my expression can be written without absolute value notation as x minus 1. Cancel x minus 1. My remaining expression is x minus 1. Do direct substitution. 1 minus 1 is equal to 0. Approaching from left, numerator is x minus 1 times x minus 1. Because of approaching by a number, any number less than 1, if I use 0.5 minus 1, it is negative, so my expression goes outside with minus sign. You may cancel x minus 1 for both, and if I do direct substitution, it will be negative 0, which is 0. Right, left limits are the same, so answer of question 16 is A. Question 17, I need direct substitution, and direct substitution is going to give us 0 over 0. So I can use L'Hopital. Derivative of numerator will be negative 2x. Derivative of denominator will be 2. And if I write 2 instead of x, negative 4 over 2 is negative 2 as the answer of question 17. Question 18, direct substitution is going to give us 0. I can use L'Hopital. Derivative of numerator is 1 over root of x. Derivative of denominator is minus 2x. And x is approaches 1. Write 1 for both. Write 1 instead of x. Numerator is negative 1 over 2. Denominator is minus 2. So 1 over 2 times minus, numerator is 1 over 2 times denominator is minus 2 minus 1 over 2. Operation is minus 1 over 4. Question 19. It is the case of oscillating behavior. If I do direct substitution, cosine over sine, number over 0 is the case of oscillating behavior. Limit doesn't exist. Whenever we have unknown in front of oscillating case, answer will be the limit is always going to be 0. X sine 1 over x, limit 0. X approaches 0, absolute value of x sine over 1 over x square is also 0. These are proved by using the Secures theorem. Question 22. It is not necessary to be x approaches 0. Direct substitution, if it gives you sine or cosine number over 0, you are in the case of limit doesn't exist. Answer of question 22 is D.